Alrighty, welcome back, boys and girls. It's your main math man, Shane, coming to you live from Summit Academy. In this video, we're going to be talking about that Unit 8, Lesson number 3, still working with our squares and square roots. And I kind of want to recap from previous lesson. So when you're talking about the area of that square, so if you're talking about, let's say, just imagine this is a square. Let's say the area inside of this square, is 19. The area of this square is 19. That means the side length, however, is going to be the square root of 19. So that means since it's a square, all those side lengths are equal. So just giving you an example, making sure you understand it. And then separately, when we are squaring a number, again, that's going to be, like x squared. This is going to be different than when we are taking the square root of a number. So if we had the square root of x. So make sure you've seen the differences between those ideas as we move through this lesson. All right, so on the first part, it says find a positive solution to each equation. And what you can do is this. I'm just saying I'm taking square root of both sides. I'm going to break it apart so that way it's plenty of space. So let me do it like this. I'm going to say for the first one, so for number 1, I have the square root of x squared equals the square root of 36. And that just means x equals 6. Then I can say the second one, for number 2, I can say if I have the square root of x squared, that's going to be equal to the square root of 9 over the square root of 4. So anytime you take the square root of a fraction like this, it's like you're taking the square root of the whole thing, which is the same as taking the square root of the numerator and the square root of the denominator. Make sure you can write it as a fraction, so I can just say this is going to be x equals 3 over 2. Again, just make sure that you're able to know those perfect squares. So now in number 3, you can find space for yourself, use that whole page. I can say I have the square root of x squared equals square root of 1 over the square root of 4, which is going to be the same as 1 over 2. And lastly, but certainly not leastly, for number 4, I'm going to take a square root to solve, again, an inverse operation of squaring something is taking the square root. So I'm going to take the square root, both sides, square root of 49, divided by square root of 25. So that's just going to be 7 over 5. So again, make sure you can use those calculations for yourself, and if you need to use Desmos, feel free to. Again, you can leave those in fraction form because we know those are going to be rational numbers. And we'll talk about that shortly. All right, in that second part, it says for this, it says draw 3 squares of different sizes with vertices aligned to the vertices of the grid. And again, when I say vertices, I just talk about a vertex. And so it says for each square, label the area, label the side length, and write an equation that shows the relationship between the side length and the area. So a couple things here, and I'll give you time to kind of try this out, but what I want to do first is I want to show you kind of what some non-examples look like. So that means they do not work. So for example, if you tried to use those vertices on the side, notice how it is not a square. So again, this one is incorrect. And this one looks like a square because it has that 4 equal sides, but it's not along those vertices and those corners. So make sure that you're using those vertices like that. So for example, I can draw, let's do a couple different ones. I'm going to say, let me get this out of here. Let's do in blue first one. So again, real easy. I can show or trace my vertices like this. And I can say, okay, what's the area going to be? So I'm going to say my area of this square. Well, I have 1, 2, 3, I have 4 squares. So that means that the side length S is going to be the square root of that. So square root of 4 is 2. So that means these side lengths are 2. When I'm looking at another one, I can draw, let's do green this time. I can use some vertices like this and say, well, if I have this, and I can say, well, the area is going to be 1, square root of 1 is also 1. So that means the side lengths are also 1. And then I can draw another one, the third one, a little bit trickier this time, but I can say if I draw, using these vertices, like we were working with the previous lessons, we have that tilted square. So you kind of draw it like this. And we could say, well, I know the area of this. It's almost like I'm cutting this in half. I can say the area of this is going to be 2. However, I have to say the side length, again, is that square root of the area. So I'm going to say the square root of that area is going to be square root of 2. So notice how it's really easy to calculate when we have the actual grid, but when we have the tilted square, it's going to be a little bit trickier. So we did part A, we did part B, and now let's do part C. So it says write an equation that shows the relationship between the side length and the area. So for the first one, let me actually move all this up real quick if I can. Like this maybe. Okay. So it says, let's say for number 1, I have, if I want to write the side length squared, so I'm saying I'm going to say the side length squared is just going to be 2 squared, which is equal to 4. I can say for my second circle, my green one, so for number 2, my second circle is going to be just 1 squared, which is the same as 1. So again, you're just saying this is side length, my side length squared is equal to my area. That's the relationship that we're showing here. And then for that last one, the purple one, I'm saying I have for number 3, that third square, again, inside the parentheses, my side length was square root of 2. I'm raising that to the second power, squaring it. I'm saying that is going to be equal to 2 because I'm getting rid of my radical symbol. I'm getting rid of that square root symbol. And so just the area of this square is 2. Again, feel free to pause, rewind as needed. For number 3, or part 3, there we go. It says looking for a solution. Are there any of these numbers? Because on that previous one, you notice how we don't have a whole number or we don't have an exact value. So we're going to try to figure out what does it look like. So it says, are any of these numbers a solution to the equation x squared equals 2? And let's explain our reasoning. So we're going to say, okay, for each of these, I'm just going to say I'm going to raise this to the second power. So that's equal to 1, which is no, because I'm trying to equal 2. So I'm going to say this is no. If I raise this to the second power, I'm going to say this is 1 over 4, which is equal to 0.25, which is also no, because I'm trying to get 2. How about if we try 3 over 2? What happens then? Same thing, I have 9 over 4, again squaring each of those, which is the same as 2.25, which is a little bit bigger, so we know that's also no, because I'm trying to get exactly 2. And what about the last one? Try this one. How about 49 over 25, which is equal to 1.96, so this is also no. So for each of these are not solutions. So I'm going to say, again, be able to explain the reasoning for this. So let's kind of summarize it. So when, say it like this, when we square or raise to the second power these numbers, again, that means raise to second power. Let me write that below. Second power. There we go. When we square these numbers, we're going to say the result or answer is not equal to exactly 2. Again, you know, I can say, well, this one's kind of close to 2 because it has 2 in the ones place. I can say this value is close to 2 as well. If we round it up, you know, to a whole number, it'd be close. But I'm looking for exactly 2, which none of these are. So make sure you can evaluate those carefully. And so let's kind of bring this together. So a quick little review. It says, what is a ratio? So, you know, if you need to pause and kind of think about what that is, feel free to. If you want to try fill in the blank first, that's okay too. But we're going to say this. We're going to say let's do this one. Let's say a ratio. A ratio is a comparison of two numbers through division. What does that look like? Well, that just means it's a fraction. And it kind of looks like this. It's going to say A divided by B, where A and B are integers. That means the whole numbers and their opposites. So integers. And specifically, we can't have B be 0 because that's in the denominator. And it says here are two different types of numbers. And so we're going to talk about irrational numbers versus rational numbers. And what I want you to say first is, if you look at that prefix IR, so the prefix IR means, so let me write means not. So anytime you see that IR, you can say, well, it means it's not rational. That's all. So what that example would be is this. I can say, if I look at the decimal form, it must not do two things. So it must not end, and it must not repeat. So when I'm looking at that decimal form of, you know, whatever value or whatever number I'm looking at, I'm going to say, well, what happens to the decimal? Does it end, meaning does it stop? If it does not, and it does not repeat, then I know it's going to be irrational. If it does either of those things, meaning if it does one or the other, then I can say it's going to be rational. So like this, I'm going to say, so that means one other thing to put with this, I can say it cannot be in the form of a ratio. Because if we had a ratio, you know, we could write it like a fraction. However, these irrational numbers, we cannot. So anytime you see a fraction, you know it's going to be rational. And a way to remember that is, hey, it starts with that word ratio. So we know it is going to be a fraction. So that means numbers that can be in the form of a ratio. So that means if I'm looking at that decimal form, it's going to say it either does one of these two things. It doesn't have to do both, because it can't do both, but it's going to do one of these. So it either ends or it repeats. So as long as it does one of those, you know it's going to be rational, or if you just see it's a fraction, you know it's going to be a ratio, meaning a rational number. If it is not rational, that means it does not end, and again, that key word in here is and. It must not do both of those to be irrational. So again, make sure you can pause, that way you can have each of those items in there. on the back. So now thinking about those ideas, we're going to say it says decide whether each number in the list is rational or irrational, meaning not rational. And what I suggest you do is this. I suggest you look at, look at decimal form. Or I can just say, hey, I know this is a fraction. This is a fraction, which means it is rational. So since it's in that fraction form, that just means it's rational. If you wanted to look at the decimal, I could say this decimal is going to be equal to, this equals negative 4.3, where the 3 repeats. So since it repeats, it is rational. If I'm looking at this next one, it's not a fraction, but if I look and say, hey, it ends, it does end, meaning it stops, it is rational as well. However, when I look at the square root of 37, I'm going to say that's going to be about, again, this is approximately, I'm going to say about 6.08. I'm going to use the ellipses, I'm going to use these 3 dots to say, hey, there's more numbers after it. If I look at that full number, it does not end, and it does not repeat. So therefore, it is irrational. So IRR. So irrational. If I look at the next one, where's the decimal at? Well, it's placed at the end. So if I said this is point, 0, well, hey, that ends very simply. So it ends. That means it's rational. If I can write it as a fraction, I know that I have a rational number. Take the square root. Again, make sure you're taking the square root first. So take the square root of 100. So that's going to be 10. Have that negative on the outside. So I'm going to say negative 10 is what we're looking at. If I look at that value, I know it also ends. So that means it's rational. And lastly, if I look at the square root of negative square root of 12, I'm going to say, again, it's going to be approximately negative 3.46 with values after it. Again, it does not end, so it does not end or repeat. Fix that up a little bit. Or repeat. So that means it is irrational, meaning not rational. Okay, so as long as you're kind of remembering those properties that you had from that previous slide, again, making sure that you're saying, again, it must not end and it must not repeat to be irrational. But if it's in a fraction or it ends or repeats, then I know it is rational. So just make sure you're keeping those ideas in your head. Then for number 2, it says which value is an exact solution to the equation m squared equals 14. And well, first up is first. So if I have, write it down here, if I have m squared equals 14, inverse operation. So inverse operation. Again, we're trying to undo what has been done. So let me write this down, to get rid of exponent, take root of both sides. You have to be careful, and I didn't say square root because, if our exponent, let's say if we had x to the third power equals 27, we would have to take the third root. So make sure, again, it looks like a square root, but it has that 3 And so we would have to take the third root of both sides to get rid of that exponent. So anytime you're unsure of which root to take, just look for that exponent first. So we're taking the square root of this one, so that one's real simple. Take a square root. And so the only option in here is going to be option B, because we have the square root of 14. Then on the next one, or last one I should say, for number 3, it says a square has vertices, meaning it has corners at 0, 0, 5, 2, 3, 7, and -2, 5. Which of these statements is true? So only one of these is going to be true. That means 3 of these are false. And so what I suggest you do is graph points on Desmos. So if you graph these points, you'll be able to kind of see the square, because this is just like problem from lesson 2. So what I'm going to do, I want you to pause, type those in first into Desmos, and be able to see kind of what it looks like. And what you should get, it's not going to be exactly like this, but what you should get is these points. And so if you want to, you can plot them like this. So if you look, you can click on that label and it will label those points for you, so that way you can see what you have. And what I have is that tilted square again, and it's exactly like what we had before. And what I did was I have that tilted square, I have the points around it, and so I have that big square around it. And what I can do is I can find the side lengths of the big square, find the triangles inside, and then take the difference of those two. So let me actually do like this real quick. So let me take off those labels and use this tool real quick. So I want to draw it. So copy and let me paste this in here. Okay. And let me show you what I'm looking at. There we go. All right, so now what I'm saying is this. So again, try this out. It's just like our exit ticket that we had from the previous day. I'm looking for the blue square. So I find the pink square. I'm going to say these side lengths are 7. So these side lengths are 7. So I'm going to say the area of the pink square is going to be equal to 7 squared, which is 49. Then I can find the area of each of these little triangles, just like we've been doing, where this side length is 2, this side length is 5. So I say the area of these triangles is going to be equal to 2 times 5 over 2, which is equal to 5. Since I have 4 of these triangles, 1, 2, let's try to draw that triangle a little bit better. So let me just say this area inside here, this area is going to be 5. This area is going to be 5, 5, 5. So I add those all together. So I say 4 triangles, so 4 times my triangles, my area of my triangles is going to be equal to 20. Then to find this blue amount, again, use those two numbers. So I'm going to say my area of my blue square is going to be equal to 49 minus 20, which is equal to 29. So this is exactly like we did from before. However, be mindful. Looking at your choices, it's not talking about area, it's talking about the side length. So again, if this is the area of the blue square, that means the side length of the blue square is going to be equal to the square root of 29. Still don't see that as an answer, but what we can do is calculate that in there. This is going to be about approximately 5.38. And so what I can do is say, hey, if I'm looking at these numbers, I'd say it's going to be in between $5 and $6. If you're looking at, these decimals, always think of money, so that way it's easier to work with. But I can say that each of those values would be in between. That square root of 29 is going to be in between 5 and 6, or you could say 5.38 is in between 5 and 6 as well. So that side length has to be the area, the square root of the area. So make sure, again, if we wanted to write it like this, side length equals square root of area. Square root of area. All right. Please feel free to ask questions as needed, pause, rewind, anything you need. And as always, super slam that subscribe button.